I've started the recording, everybody. Hey guys, I'm live and in stereo, and some of you guys have nothing better to do in life than to take my class on a weekend. That's kind of, I love it, but the thing is that this just goes on to show that you guys don't have anything better to do. I'm joking. I'm joking. I'm glad that you guys are here. I'm glad that unlike all the other Dumbo Jumbos, some of you have actually showed to the class just to do more chemistry. I love it, right? Now, what you guys need to understand is that I am solving the topic wise booklet, the topical booklet that I've curated very carefully. It's almost 1800 pages. And I've done, I'm making these video solutions. I've been making these video solutions since last year or 2 years ago when I made the booklet live. So I've been making these solutions and I'm going to continue to do these questions with you guys so we have a proper ordered video solutions for you guys if you guys ever were to watch those. So I'm going to start from here because before this, we've already covered this. When did I cover this? I covered all of this in the last session. So if you guys are interested, it's already present on your portal under the name Topicals. So it's present on your portal under the name Topical. You can find all of this video solution that is already done and even the written marking scheme for it that I've written like this, right? But I'm just going to continue off from 2020 and here we go. And by the way, Abbas, beautiful, beautiful singing. At the start of this class, Abbas sang for us. So Abbas, if you're watching this 5 years down the line, I hope you know that you have a good voice and I hope you've become the next Atif Aslam. Yes. Okay. Now, without further ado, I would need your guys' participation. Inshallah, I would need your guys' participation when I solve these questions. And here goes nothing, right? So you guys can use the chat box to give me your no, not unsolicited, solicited opinions and answers, right? So it says ammonia is a gas prepared at the front of a laboratory. The pungent smell, pungent just means strong smell. This one, ammonia smells like piss. It smells like pishy. So the pungent smell of ammonia spreads throughout the laboratory slowly. Name the process that occurs when ammonia gas spreads throughout the laboratory. We've already done this. It's called diffusion, Sararino. That's diffusion. Done, sir. Next, explain using ideas about particles. See, talk about what happens to the particles. Why ammonia gas spreads throughout the laboratory. So, why do they spread? Because you know that something known as spreading is basically something known as diffusion, right? So, something known as diffusion is actually taking place. Now, you have to explain it by using the idea of particles. What happens to the particles when they diffuse? What happens? Well, particles move from a region of particles move from a region of high concentration. Region just means area. So from a region of high concentration to a region of low concentration. That's it. That is the reason low concentration. That is the reason why ammonia gas is going to spread throughout the laboratory. And you also need to tell me the ultimate reason. So particles do spread from a region of high conc to a region of low conc. And how do they do that? They do that, by moving randomly because you know that particles are supposed to move randomly. That is the entire idea behind diffusion. He's saying, why do gases diffuse? Because they move randomly at high, for gases, it's they move randomly at high speeds, or they are in a constant random motion, due to which the particles move from a region of high concentration to a region of low concentration. So particles move from a region of high conc to a region of low conc due to their random motion. Yeah. That's it. And you guys, this is for 2 marks. First mark for this and the second mark for this due to their random motion. Particles move from a region of high conc to a region of low conc. And you guys can talk about colliding with air particles, blah, blah, blah. That's up to you. Explain why carbon dioxide will spread throughout the laboratory at a slower rate than ammonia gas. It's pretty easy. Why would carbon dioxide spread slower? Why would it diffuse slower? See, carbon would diffuse slower because O levels does not have negative marking. It would diffuse slower because it has a higher relative molecular mass. See, the higher the relative molecular mass, the fatter the molecule is. No, not smaller. Not smaller. Why do you guys think smaller? It moves slower because it is fatter. It has a higher relative molecular mass. How do I know this? You can even calculate this from the periodic table. Ammonia is nitrogen is 14, hydrogen is 1, times it by 3. You've gotten 17 as the mass for ammonia. Carbon dioxide, carbon is 12, oxygen is 16, times it by 2 because you have two oxygens. So carbon dioxide is 44. Which one is fatter? Carbon dioxide is fatter. It has a higher relative molecular mass, so it will diffuse slower. Yeah. So because of higher MR of carbon dioxide. Yeah. And you could even mention it. That is 44 versus ammonia, which is 17. Easy. आसान है हलवा हलवा या हबीब हलवा zinc is manufactured from zinc blend gotta remember the obesity rates of compounds. Zinc is manufactured from zinc blend is an ore which consists mainly of da 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 zinc oxide, then is converted to zinc sulfate da 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 da. Hot air is blown into the zinc at the melting point. That's our concern. Zinc has a melting point of 420 and a boiling point of 907. The temperature inside the furnace is 1200 degrees Celsius. Hold up a moment. Hold up. The temperature inside the furnace is how much? It's 1200 degrees Celsius. And the melting point of zinc is 420. That means that zinc goes from solid to liquid at 420. After 420 is going to be a liquid. And when does it go into a gas? That's the boiling point. At 907 degrees Celsius, the zinc actually goes from a liquid to a gas because that's the boiling point. Boiling point is the constant temperature at which a liquid goes into a gas. Melting point, the constant temperature at which a solid goes into a liquid. Now, after 907, what will you have? After 907, what will you have? You're going to have a gas. You're going to have a gas. So at 1200, it says, explain how this information shows that zinc produced inside the furnace is a gas. How do you know that zinc produces a gas? Yes. How do you know that zinc produces? This is such a pathetic color, man. Let's use another color. Sorry, guys. Oh, it's very not nice. How do you know zinc is a gas? Because, yes, thank you very much. We've already done this because 1200 degrees Celsius is above the boiling point. Yeah, 1200 degrees Celsius is above the boiling point. Easy peasy lemon squeezy. Or you could say, yes, you could even say the temperature inside the furnace is 1200 degrees Celsius, which is higher than the boiling point of zinc, obviously. Yes. So 1200 degrees Celsius, which is the temperature in the furnace, the temp of the in the furnace, probably in furnace, is above the boiling point of zinc. The gaseous zinc is converted to molten zinc. Okay, so gaseous zinc is converted to molten. Molten means liquid. Yeah. Name this change of state. So gas to liquid. What is this called? It's called condensation. आसान है कि मुश्किल है guys? Is it easy or is it difficult? Very easy. I know. I know. This question's about halogens and halogen. What in the world are halogens? I don't care, whatever it is. I just have to read the question. It says a drop of bromine liquid, which is Br2 liquid, was placed in a sealed glass jar. So you have a sealed glass jar and you have Br2 that's being placed right here. Yeah, it's liquid. Now it says after a time, the color of bromine spreads throughout the jar. What is this process called, guys? The color, the red-brown color of bromine spreads throughout the jar. What is this process called? Everybody's saying it's called diffusion. You all are right. You all are right. But before diffusion, something else happens. Before diffusion, this liquid goes into what? This liquid goes into what? If bromine is spreading throughout the jar, if the color of bromine is spreading throughout the jar, that means bromine liquid is going into what? Bromine liquid is going into what? Yes, bromine liquid is going into bromine gas. That's how it is spreading everywhere. That's why it's spreading everywhere. This was a liquid droplet. If you put a droplet of water on your table, it doesn't go anywhere, right? But it starts to evaporate slowly and gradually. That's how it starts to take up the space of this entire jar. So if it's saying the color of bromine spread throughout, that means that first the evaporation must have taken place. This liquid would have gone into a gas, and then it would have also diffused. So evaporation and diffusion both are taking place. So what am I going to say? I'm going to say evaporation takes place. Evaporation takes place, and particles diffuse from area of high conch from an area of high conch to an area of low conch, colliding with each other and da 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 da, colliding with each other and the walls of the container. So colliding with each other and walls of the jar. See, you're adding ink to water, right? So it doesn't go into a liquid, right? It doesn't go into a gas. It's already a liquid. So the liquid just spreads inside water. Hmm. Yes, you could also say the particles, mix with the air particles. Yes. Yeah. And hence they spread throughout. Hence spread throughout. Mixing. Same is the case with polluted air. Yes, in polluted air, what happens? The pollution basically, I don't know what the problem with my AC is. Something's wrong. Let's see. But what was I saying? I was saying, yeah, in pollution, what happens? The polluted air particles like SOx, NOx, they all mix with the air particles because they diffuse from an area of high conch, which is your factories, to an area of low conch. Yeah. Yes, you could also say due to the random movement. Yes, this also has a mark. Due to their random motion. Due to their random motion. You could add it here. It's a 3 mark question, so I've added like 5 marks to it. Evaporation takes place, particles diffuse from an area of high conch to an area of low conch. Why? Because they have a random motion. They collide with each other, the walls of the jar, hence spread throughout. तुझको Hydrazine! Oh my god, sir, what in the world is this name? Hydrazine, NH2, NH2. I've never seen this. I don't care. Even if you've not seen it, just read the question, please. So it says hydrazine is a colorless liquid. Okay, it's a liquid. I've studied states of matter. I know what a liquid is. The melting point of hydrazine is 2 degrees Celsius. Let's make our handy line. So the melting point is 2 degrees Celsius. That's the constant temperature at which the solid goes into a liquid. And the boiling point is 114. That means that's the constant temperature at which the liquid is going to go into the gaseous state. Question. Use this information to explain why hydrazine is a solid at zero. Yes. At zero, why would it be solid? Because 0 degrees Celsius is above the melting point, but below, sorry, it's not above the melting point, it's below the melting point. Zero is here, it comes before 2. Sorry, my bad. Okay, chill. Thank you for correcting me. That's what you guys want to take out. I'm joking. Thanks, guys. So zero is before two. What in the world was I saying by writing it? So what happens at 0 degrees Celsius? It's a solid. Why? Because zero is below the melting point of hydrazine. And obviously, if it's below the melting point, it's obviously below the boiling point. So we don't need to mention that. So 0 degrees Celsius is below the melting point of hydrazine. Yeah. I don't know what the hell is wrong with my AC. I swear to God, something's wrong with it. I came back home after after like 2, 3 weeks to Islamabad, and just something is wrong with this stupid AC. I don't know what it is, but it is. I don't know what's wrong, but it's wrong. And it's not working for some reason. It's just tripping. Why are you tripping, my G? Why are you tripping? Don't trip on me. Don't do this to me. Don't do this to me. It's doing. AC air is not diffusing, man. That's kind of funny. Yeah, it's not. I swear. It's literally something's wrong with it. I don't know. Let's see. We're gonna look into that later. A drop of black ink is placed at the bottom of a beaker of water. After a time, the color of the ink spreads throughout the water. Explain this observation using the kinetic particle theory. Yes, what happens? So, diffusion takes place. Diffusion takes place. Particles move from an area of high conc. Particles move. Ink particles, yeah? Ink particles move from an area of high conc to an area of low conc. You don't need to write conc. You're not going to write conc in the exam. Concentration full. An area of low conc. Why do they do that? Due to their random motion. Random motion. Colliding. Colliding and mixing. Colliding with particles and mixing and da 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 da. Whatever. Yeah, you just need to talk about the ink particles at this point. Sliding over the water particles. Sliding over? They're not sliding over the water particles per se. They're just mixing with the water particles. I swear something's wrong with this AC. I just turn it off. Yes. Yeah, गर्मी में पढ़ाना पड़ेगा 20 मिनट because I don't want the voice to be distorted. इस कहानी है सर आपकी वॉइस एंड एक्टिंग स्किल्स एक गेमर की तरह और कमेडियन की तरह है. I'm joking. I'm joking. I should take this as a compliment. Sir, states of matter not on your side today. True, true. I'm being punished for taking a class on Saturday. The melting point of sulfur dichloride is minus 1 to 1. The boiling point of sulfur dichloride is 59. Reduce the state of sulfur dichloride. Room temperature. Room temperature is what? 20 or 25 degrees Celsius. In science, you could either take 20 or 25. Doesn't make a difference. So melting point is minus 1 to 1. Boiling point is 59. Now see, room temperature is here 25. It's above minus 1 to 1, right? But below 59. So melting point is the constant temperature at which solid goes into liquid. Boiling point is the constant temperature at which a liquid goes into a gas. So at 25, obviously at minus 121, it would all the solid would convert into a liquid, and after minus 121 it will be a liquid. Till which point? Till 59. So from minus 121 all the way till 59, it's gonna be what? A liquid. So what is gonna be the state? It's gonna be a liquid. Why? Because 25 degrees Celsius is above the melting point, but it's not a gas, so but below the boiling point. ओ रे साजना तू जो ना मिला. आसान है कि मुश्किल है? This is literally Cambridge exam questions. ये क्या है? इसमें क्या है? Literally 2 free marks, one for stating that it's a liquid, one for giving the reason. Remember when I was teaching you guys all of this good stuff? Okay. Complete the table about solids, liquids, and gases. This is a very crucial table. Very crucial table. Why? I'll tell you in a moment. Particle separation of solids. Now, there's something in science which we call this. What have I written? What does this mean? What is written? This is what Cambridge stresses on. Cambridge says, please give me question specific answers. What does that mean? That means if I am saying that liquid particles are touching, gas particles are apart, what should you write in this blank? Should you write they are close together or should you write they are touching? Should you write they are close together or should you write they are tightly packed or should you write they are touching? Like Aisha is saying, sir, they're tightly packed. Oh my God. The examiner says, uno, dos, zero. Arush is saying it's a lattice, it's a days. It's all true. All of these statements are true. Close together, all of these statements are true. But What I'm going to do is I'm going to look at what the examiner has done. And when I look at that, I say, hey, the examiner has written touching. So the solid particles are also touching. Rather than writing closely together and closely packed, tightly packed, da 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 da, I'll use the word touching. Yes, closely touching, nahi, but touching. That's it, touching. Both are. See, liquid particles are also touching, but slightly separated. But if this was touching, this was apart, I would write touching here as well. Particle arrangement. If I talk about particle arrangement, solid particles are regularly arranged. Gas particles are random. Should I write random here or should I write irregular? Liquids are not regular. Should I write random or should I write irregular? Obviously, I'm going to write random, not irregular, because liquid particles are also randomly arranged. And I'm going to be exam specific. So regular, random, random. See, I've taught you, you could write that the structure, the liquids have an irregular arrangement, or you could say a random arrangement. But since the word random is written here, I'll write random. That's what exam specific means. That's the reason why I'm doing these questions. Solid vibrates only, liquid type of motion random. See, although we know that liquid particles they slide over each other. We know liquid particles slide over each other, but he's written random. What should I write here? What should I write in? I should write the word random. That's called being question specific. No need to write high speeds here. Although I know it's random at high speeds, but I'm being question specific. हम्म मेक सेंस वैसे ही आती है स्टार और क्या द ग्राफ शोज द चेंज इन टेम्परेचर एंड देन स्टूडेंट से सर हमने तो सही किया था ये वो बिकॉज दे राइट क्लोजली पैक्ड डा 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 they mess it up. The graph shows the change in temperature as a sample of a gas is cooled, as a sample of gas is cooled. Now you have a gas. He's given you the starting point. The starting is a gas. Here it's a constant temperature. That means gas goes into a liquid. Here the liquid cools down. Here this is a constant temperature, so the liquid goes into a solid, and the solid further cools down. Now it says name the change of state taking place between A and B. That's called what? Name it. Don't write gas to liquid. Name it. It's called condensation. Done, sir. A to B. And what is happening here? From B to C. No, so falling from C to D. Freezing. Yeah. What's the condensation point? Well, the condensation point would have been this temperature right here. What's the freezing point? It would have been this temperature right here. What's the boiling point? It's this temperature. What's the melting point? It's this temperature. Not zero. Rakir ke fakir. Not zero. Did the examiner tell you that this is water, which you guys are saying zero? It's not water. The examiner has not mentioned whether it's water or not. Everybody is saying zero. Laqiyq faqir. I swear to God, man. I love it. Sir, from C to D, can we write solidification? No. You'll write freezing. That's the process. Solidification can also be from gas to solid, from gas to being converted directly into a solid. That's also solidification for you. Take it now. Please be exam specific and scientific. A bottle of liquid perfume. Sublimation does not come like this. You don't need to know the graph of sublimation and solids. Sorry, and desublimation. A bottle of liquid perfume is left open at the front of the room. After some time, the perfume is smelt at the back of the room. Name two physical processes. It was liquid perfume, remember. So if it was smelt at the back, that means the liquid must have gone into a gas. Evaporation would have taken place. Why condensation, guys? I don't get it. Why is it condensation is gas to liquid? So evaporation would take place. That's how the vapors would have reached the back of the room. And along with evaporation, diffusion also takes place. So the two processes are evaporation and diffusion. Awesome. Sir, once this question came, I wrote freezing. Oh my God, this is so amazing. Wow. Oh my. I'm joking. I'm joking. I'm just kidding. Table shows some of the properties of five esters. Oh my God, what in the world did this? I don't know what you shouted. Please read the question completely. At 25, ethyl ethanoate is a liquid. Explain how the data in the table shows this. So that's written right here. So how would I know which one is ethyl ethanoate? It says ethyl ethanoate. आंखें पाड़ के देखें और इधर देखें क्या लिखा हुआ है ethyl ethanoate, and then you look at the melting point and the boiling point for it. So the melting point for ethyl ethanoate is what? Minus 84, and the boiling point is what? 77. So why is it gonna be a liquid at 25? Because 25 is above the melting point but below the boiling point. 25 degrees Celsius is above the MP but below the BP. Yeah, and you could even mention the MP minus 84 and 77. Yeah, makes sense, everybody. Let's go. Carbon dioxide is a colorless gas found in air. When warmed, solid carbon dioxide changes directly into a gas. It does not become a liquid. Use the and what is this process called? This process called what? Sublimation. Yeah. It says use the kinetic particle theory to describe the changes in movement and and arrangement of particle during this state. So sublimation takes place, I'll write that, but takes place, I'll write that definitely. But see, he's talking about the movement change and this arrangement change. So we went from solid to liquid. What is the change in movement? Movement. I'll write it. Movement. The carbon dioxide particles went particles went from vibrating, vibrations, or vibrating in a fixed position to what? To moving randomly at high speeds. I'm going to mention the, the movement of solids and the movement of gases. Oh, sorry, not liquid. Yes, gas, obviously. So went from vibrating in a fixed position to a random motion at high speeds. This is not gas, this is solid. Speeds. And what's the arrangement change? What's the change in arrangement? When carbon dioxide solid particles went from, or you could just say the arrangement went from a regular arrangement, changed to a random arrangement. Done. Yes, from lattice of particles to random arrangement. Yeah, makes both are correct. Yes. आसान है ये मुश्किल है guys? Is it easy peasy lemon squeezy or is difficult difficult? Explain how methyl methanoate is a gas. Explain how. Well, it's a gas because at 35 degrees Celsius, because 35 degrees Celsius is above the boiling point. And you could even refer to the table. The table is what? The table is showing you methyl methanoate. That's 32, which is 32. So refer to the table, which is 32. Yeah. See, he's saying what's the state at 35? It already boiled at 32. So at 35, it's obviously going to be a gas. Zainab saying, I just fell down the stairs. Oh my God, no, Zainab. Oh my God. I'm joking. Zainab, I hope you're well. Zainab, I hope you're fine. Sorry for being so inconsiderate. That's just me. Liquid sulfur dioxide is stored in cylinders. When the cylinder is opened, the liquid quickly changes into a gas. What is this called? It's called evaporation. Use the kinetic particle theory to describe the change in movement and arrangement. So evaporation takes place And what's the changes? Well, you go from particles go from sliding over each other. That's the motion, right? So particles go from sliding over each other to random motion at high speeds. High speeds. Yeah. And what about the arrangement? You go from an irregular or random arrangement, you go from an irregular arrangement to a more random arrangement, or a random arrangement to a more random arrangement. Yeah. Makes sense? Yes, sliding motion to random motion, whatever. Which substance is a liquid at 25 degrees Celsius? Well, the substance which would be a liquid at 25 would mean that it must have melted, but it must not have boiled. So at 25, if something is a liquid, that means 25 degrees Celsius should be above the melting point, but below the boiling point. Check this out. These are the melting points. So 25 degrees Celsius should be above the melting point. The only two temperatures above the melting point are minus 119. So the only two temperatures, sorry, the only two temperatures which are below 25 degrees Celsius are what? It's minus 119 and 210. So it's F and I. Now, you also have to make sure that it's a liquid. So realize that the 25 degrees Celsius that you have, the boiling point should be above 25, not below it, because if it were below it, then it would not be a liquid at 25, it would be a gas. So the boiling point should be above 25. Between these two, in which case is the boiling point above 25? That's right here, 43. Here it's minus 196. So at 25, this substance would be what? This substance would be a gas, because 25 degrees Celsius is above the boiling point. Yeah. So which is the correct option? That's F. Why? Why is F? If he asked why, because the melting point is below 25 degrees Celsius, but the boiling point is above 25 degrees Celsius. That's why it's a liquid. Which substance is a gas at 25 degrees Celsius? Well, if it were a gas, that would mean that 25 degrees Celsius would be above the boiling point. And is in which case is 25 degrees Celsius above a number? It's above in case I. So in case I is gonna be a gas. Why? Because 25 degrees Celsius is above minus 196. So you just have to read the question. Sir, the people are going wild. Which people are going wild? Who? Okay, chill, 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 chill. Adnan, I got it. You are awesome. Appreciate it. Ooh. Appreciate it. Define the term element. Yes, define the term element. As if you guys can't define it. Yes, Bolenji, what is an element? A substance, a pure substance made up of one type of atom, of one type of atoms, or single type of atoms. The keyword is one type, single type, da 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 da. Yes, a substance that cannot be broken down by chemical means into simpler substances. That's also correct. Ethanoic acid is a solid at 60 degrees Celsius. Describe the arrangement and movement of particles in the solid. What's the movement and the arrangement? Tell me about the arrangement, tell me about the movement. What's the arrangement in solid? It's it has a regular arrangement, right? Or you could say it is a lattice of particles. Yeah, it's better when they say describe, it's better to write the word regular arrangement. It's a regular arrangement. What's the movement? Vibrate about a fixed position. A fixed. See, that's the problem. Students who are just gonna write regular here and vibrate here. Examiner says I have written description. So describe it. The particles have a regular arrangement. The particles vibrate about a fixed position. So don't just write words, like don't state it. There's a difference between state and this. A state just means just write one word. Describe means write a little, a couple of words to make up a phrase to describe. The melting point of ethanoic acid is 16.7. The boiling point is 118. What is the physical state of ethanoic acid? So 16.7, it will melt, go from solid to liquid. Yeah. Uh, at what will be this at 118? It'll go from liquid to gas. What's the state at 130? Obviously, after 118, it's all gas, gas, gas. So at 130, it's a gas. Why? It says explain your answer. Why? If you just write gas, you'll get zero. Explain your answer. Why? Because 130 degrees Celsius is above the BP. Did you guys see the CEO who got caught during the Coldplay concert cheating on his wife? That's crazy. With his HR head. That's wild. The world is just. Yes, you made a meme about it. I did not make a meme about it. I have a student who handles my social media page for me. So he makes all these memes and everything. I just hired him because he was doing a wonderful job. So he handles all the pages. I don't have the time to make memes. How much did you pay him? I paid him quite a lot and I will continue to pay him. I paid him a lot of money because he has a talent. You should appreciate talent, skills. He's making me laugh. As long as he's able to do that, I love it. Mhm. How did you get to know about? He just started making posts for me and I was like, hey, I love your content, do you want to join and just work for me? He said, yes sir, why not? And yeah, that's that. He's an awesome kid. Is it free labor? No, I pay him quite a lot of money. Quite a lot. For your level, that much money, you guys will be like, oh my god, son, really? Oh my god. So it's quite a lot of money for an O-level student, even an A-levels, even university students. It's acha man. How much estimated? I won't say it in the video, I'll just write it. Ush. It's because he's not charging me anything. I'm just giving it as a gift for him because he's doing a wonderful job. Hair. That's not a lot, but for it's just been 10 days. For an O-level student, I think that's a lot of money, isn't it? फिर शायद आप हम बहुत ज़्यादा पैसा है फिर हैं? Not a lot. चलो ठीक है. तो आपको लगता होगा भाई. Complete the table by estimating the melting point of sodium, the atomic. See, he's saying estimate the melting point of sodium. So it's pretty easy. How would you go about it? I haven't taught this because I realize that you guys may be able to do it on your own. If you see the trend, what's the trend? It's you're going from 181 to 63 to 39. So what should this in between value be? Just an estimate. Somebody's saying 90, some are saying 80, all are correct. Literally all are correct. So somewhere, just make sure it's below like 180, like because see, the jump between these two can't be that high. There must be something in the middle. So I'll just say 90 or 95 or 100. It's just logical. And if you actually want to calculate it, I'll tell you what you could do is you could add these two values and divide it by 2. What do you get? If you want to properly estimate stuff, you could add these two values and divide it by 2. What do you get? 181 plus 63 divided by 2. What do you get? 120. So if you actually wanted to be in all calculative, you could have written 120 here. But the examiner is going to give you, I think the range here is from 70 to 170. You could write anything in between, you know. Because if you write 175, that's pretty stupid because after 181 is the jump only of 6 between these two. That's not, it's quite a jump, yeah. And here the atomic radius, it's going bigger. 157, 191, 235. So add, like, if you see the 40 is being added here, almost 40 is being added here. So add 35, 40 here. What do you get? 0.270 probably. I'll add that 0.270. Yeah. So it's logical. This question is logical. The examiner would probably give you a value from 0.240 to like probably around 0.310 or 0.320, something like this. This would probably be your range. और मतलब इतनी range दे दी बस ना. The melting, use the information in the table to suggest why is it difficult to predict. So we can write any estimate. No, you're not going to write range. This is what the marking scheme is going to say. That if student has written 141, 142, 143, he's going to get a mark for this because it's saying by estimating. But make sure your estimate is now. You can't write 200 here. It doesn't make sense. It's going down. And you can't even write 10 here because this is 39. How can this be 10? Yes, so just make sure you're good with estimations. It's pretty, there's nothing to teach here. Yeah. Khair, relative thermal conductivity. Why is it difficult to predict the relative thermal conductivity of potassium? It's difficult because you can't see a trend here. See, it's 84. It goes up when you go from lithium to sodium. The thermal conductivity goes up, and then if you see sodium and rubidium, it's going down. So there's no trend. I can't see any trend. That's why I can't predict it. So it's pretty logical, huh? I can't see any trend. Examiner, I can't see any trend. Okay, be a little scientific. There's no trend. There is no trend. Trend to help estimate it. The values go up and down, fluctuate. The values fluctuate. Yeah. Sir, will the class be over at 9 or at 10? Sir, I'm tired. Just a little more. Just a couple of more. Let me just finish 2019. देखते हैं किधर तक है 2019. Just a few more questions. Literally, just a couple of more questions, right? So I can say that I finished, almost how many papers? How many papers in 20 in 1 year you have uh 3 plus no, you have 1 2, you have 3 in IGCSE, 3 variants, and you have 2 in O levels, so that's 5, and then 5, that's 10, that's 11. So in 1 year you have 11 theory papers, right? 11 theory papers with different variants. So I have covered 11 plus 11, 22 papers for this topic for you guys. It's just theory for now. Question so repetitive it made chemistry look easy, isn't it? That's what I say, Alina. If your concepts are clear, questions, they might seem repetitive to you because your concepts are now clear. For somebody who's looking at these questions, they wouldn't be able to extract what the examiner is trying to ask them. You know, They'd be just confused between, oh, butanoic acid is a carboxylic acid, sir. Organic chemistry is being tested in states. You read the question. It says describe the movement and arrangement of particles in liquid. So in liquid, what's the movement and arrangement? Particles slide over each other. Yeah. And the movement and the arrangement. They have a random arrangement. Irregular, random particles are arranged irregularly. They have a random arrangement. Same thing. Melting point is -4, boiling point is 66. What is the physical state at 0? So at 0, what's the melting point? That's -4. So it already melted, right? Melting point is the constant temperature at which a solid goes into a liquid. Boiling point is the constant temperature at which a liquid goes into a gas. So at 0, it's what? It's a liquid. Why? Because 0 degrees Celsius is above the MP, which is -4, but below the BB, which is 166. Z is a covalent substance. I don't care because I haven't studied chapter 3 in an experiment, a sample of pure solid. Okay, I've come across the term solid. So a solid was being heated for 11 minutes. Okay. The graph shows how the temperature changed during the first 9 minutes. Great. So he's shown me first 9 minutes, not the first 11 minutes. What's the melting point of Z? So you started off with a solid. How do I know that? That's literally what the examiner told you. The solid was being heated. So what's the melting point? Remember, melting point is what? It's the constant temperature at which a solid changes its state into a gas. So when is the temperature constant? On the y-axis you have temperature. So when is it constant? It's constant right here. So the solid changed its state into a liquid. Yeah. So that's 80. 80. Yeah, makes sense. The sample of Z began to boil at 9 minutes. Oh, that's nice. And it was boiled for 2 minutes. So 9 plus 2. 9 plus 2, 11. So if it started boiling at 9, see that's 9 right here for you. He's given you the graph till 9 minutes right here. That's 9. So it started to boil at 9 and it boiled for 2 minutes. You have to make a constant line from 9 to 11. Why? Why a horizontal line? Why do you need to draw a horizontal line? Everybody, anybody. Why a horizontal? Because boiling point is the constant temperature at which a liquid changes its state into a gas. And that constant temperature is what? 220. So he did not say it evaporated. He said it boiled, right? So it boiled as 220. And that's why it's a constant. Oh, my bad. I've drawn it. And then it says, um, use the information to sketch on the grid how the temperature of the sample changed from 9 to 11. I literally did. I made a horizontal line. The sample of pure Z was continuously heated from 2 to 5 minutes. Explain in terms of attractive forces why there was no increase in temperature from 2 to 5 minutes right here. Why is there no increase in temperature from 2 to 5? Yes. Anybody? Yes. So yes. So energy, there's no increase in temperature because heat energy, not just energy, the heat energy is used to overcome the intermolecular forces of, you know, attraction. So is this 2 marks? Yes. Do you know why it's 2 marks? Because you're going to get 1 mark to overcome the forces of attraction, and the other mark would be for molecule. Because if you were to write it and break it down, some students they tend to write it like this: the heat energy overcomes the attraction. If they write this, they are going to only get 1 mark. But if they say heat energy overcomes the attraction between molecules, now they're going to get the second mark here. So that's why if you write intermolecular forces of attraction, it already covers the concept of molecules. Examiner knows you know what molecules are. So some students, they only write heat energy overcomes the attraction. Examiner says between what? That's why they give you 1 mark for it. मजा आ रहा है chemistry. Actually you are now in the brain of the examiner. You're like, hey, hey, examiner, oh my god, I'm in your brain. Try to try to deceive me. Let's see. Describe how the motion of particles changed from 0 to 2. How did their motion changed? How, this is a good question actually. You might say, sir, they are still vibrating on part C. You can't see the second point on part C. It says between molecules. और मैग्नीफाई कर लूं और 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 I'm joking, sorry guys, I just like to mess with you guys. Now from 0 to 1 minute, what's from 0 to 2 minutes, they vibrated at 0, they also vibrated at 2. So what's the problem? What is the change of motion? The motion is the same. They were vibrating at 0, they're still vibrating at 2. They were vibrating at 20, they're still vibrating at 80. They haven't stopped vibrating, they're vibrating, but the vibration just gets faster. That's the change, because increase in temperature makes the vibration. That's the change. So this is how does the motion change from 0 to 2 minutes? Well, the molecules vibrate faster. start to vibrate faster or vibrates faster, or the vibrations increase, whatever. 1 mark for vibration, 1 mark for increases, 1 mark for vibration, 1 mark faster. The experiment was repeated using a pure sample of impure Z. Suggest the differences, if any, between. Skip this for a moment. You'll learn this in chapter 2. Skip. Learning this in chapter 2. What are impure substances? Chapter 2. A sample of pure Z was allowed to cool from 120 to 20. The total time taken was 8 minutes. Okay. A sample of pure Z. Okay, great. The starting from point X, sketch the grid how the temperature of the substance of pure Z changed between 0 to 8 minutes. See, seeing she's cooling it from 80 to 20. From 120 to 20, sorry. And the total time taken was 8 minutes. Start sketching it from 120 to 20. Okay, how do we do that? Well, for that, you have to also look into the above question. In the above question, you realized that at what point did it start to melt? At what temperature did the solid start to melt? It started to melt at 80 degrees Celsius, right? So at what temperature would it freeze? When you cool it, at what temperature would it freeze? That's why you need to link boiling point and condensation point and melting point and freezing point. If it melts at 80, it is going to freeze at 80 as well. Why? Because melting point and freezing point are the exact same. I've said this a billion times. It just depends on whether you cool it or heat it. If you cool it, you call it the freezing point. If you heat it, you call it the melting point. At what temperature, if 220 was the boiling point, at what temperature would it condense? At what temperature would it condense? At the same temperature, at the same 220. So if you start off with 120, do you have a gas or do you have a liquid? This was actually a good question. Do you have a gas or do you have a liquid? You have a liquid. So when I'm going to cool it, I'm going to go from 120 to 80, and then 80 would be my horizontal line, and it should be for 3 minutes, because if it took 3 minutes to melt, it would take 3 minutes to freeze. So at 120, you'd have a liquid, you cool it down for the first 2 minutes, it freezes for the next 3 minutes, further cools down. Yeah. So at 120, I cool it down for 2 minutes till 80, because at 80, it's going to freeze. So sorry for my drawing, but hey, it's gonna freeze right here at 80 and for 3 minutes. So I'll drag this till 50 and then I'll just go below to show that it was a liquid at 120, went from liquid to solid here, and the solid just further cooled. Yeah. So draw it for the first 8 minutes. I have drawn it. Here you go. 0 to 8 minutes. So I just drag this further. Asan? आसान की मुश्किल बस खत्म oh last question last oh what the hell okay 2 more questions let's talk about this use the kinetic the waste includes both सर बस हीटिंग कर्व का उल्टा कर दें यस हीटिंग कर्व का बट यू ऑल्सो नीड टू अंडरस्टैंड कि शुरू लिक्विड से हो रहा है कि सॉलिड से हो रहा है देखो यही तो गलती करते हैं ना शुरू लिक्विड से हो रहा था सॉलिड यू नो दैट इट बॉइल्स एट 220 so it condenses at 220 so at 120 you were the starting point was liquid but last question last 2 questions glass waste is melted and then made into new objects use the kinetic particle theory to describe the changes in motion and arrangement of the particles when a solid becomes liquid so solid a liquid what happens to the arrangement go from a regular arrangement to a random arrangement. It's good. Right. Shabas. Likhe. And what happens to the motion? Your hand hurts? Think about my hand. You go from vibrations to sliding over each other. मेरी भी उंगलियां टूट गई हैं Hi, last question. One of the plastics is in it. Who the world? Don't do this. Don't do this. And that's organic chemistry. Khatam. Don't do this. ये करें बस ना कहीं 2018 करूं कि ना 2018 के सवाल करने इट्स लिटरली रेपिटेशन यू वांट मी टू डू इट थोड़ा सा ये देखें देखिए सॉलिड टू गैस दैट्स सब्लिमेशन I'm just writing solid to gas. This process is sublimation. Number two is this gas to liquid. That's called what? Gas to liquid is called condensation. Number three is liquid to solid X. That's called liquid to solid. That's called freezing. And number one is solid to liquid. That's called melting. And now I'll erase it because I wrote so pathetically. What is this? What is five though? What is five? Liquid to gas. The five is boiling. 2 is not boiling. 2 is condensation because he's going from a gas to a liquid. 5 is boiling. Done, guys. Any questions? Do you guys think that states of matter is difficult? Please do the MCQs. The MCQs are uploaded on the portal. It's all it there are like 110 MCQs, I think, for states of matter. All throughout. It's almost 100 papers. In 100 papers, 110 MCQs of states of matter were tested. So I would love for you guys to do that on the weekend. It's uploaded under the tab of, I think, topical or practice. I think it will be uploaded under the tab of practice. It would say states of matter MCQ. Did you guys enjoy today's class? Kwashiorkor. Kwashiorkor, I think, happened because of vitamin or protein, something like that. I think protein or vitamins. सर कब तक स्टेट्स ऑफ मैटर टॉपिकल्स खत्म करने हैं हमने अपनी प्रैक्टिस में जब आपकी मर्जी हो रयान whenever you think whenever you think you should be done with it it's up to you just do a couple once you've done a couple go over the others now what I would suggest is doing the above ones the ones from 2020 and above and below this just give them a look give them a read that can you understand the question just give them a read can you understand this question can you understand these questions and if you can that means you're good to go it's not important that you do donkey work and write it down with your hands every single time. Enjoy, of course, but I will make sure to beat the examiner after this. Okay, that's great. When will I become famous, guys? When will I have 1 billion? Guys, fun fact, we have 100 students in AS level chemistry. I might just stop teaching O level and just focus on AS level. But the thing is that I love O level, teaching O level as well, because you guys are new minds and, tiny, tiny brains, trying to develop you guys into new scientists to upcoming scientists and entrepreneurs and geniuses and logical thinking and मेरा सर मजाक करो सॉरी गलती में इधर उधर निकल जाता हूँ गलती से सर डू यू नो हैविंग अ टाइनी ब्रेन्स मीन्स यूर स्मार्टर हम छोटे बच्चे हैं और आप हमें छोड़ के जा रहे हैं अभी ना जाओ छोड़ कर कि दिल अभी भरा नहीं अभी ना जाओ छो even my Zoom is saying playing music question mark कि दिल अभी भरा नहीं अभी नहीं सर यू लुक लाइक हसन रहीम और नहीं हसन रहीम क्या मुझे आप किसके साथ कंपेयर करो किसी साइंटिस्ट के साथ करो हसन नहीं या किसी एंटरप्रेन्योर कहो बिल गेट्स की तरह दिख रहे हैं या मुझे कहें वॉरेन बफेट की तरह दिख रहे हैं मजाक करो यार हसन रहीम इज अ गुड गाय आई वेंट टू हिज कॉन्सर्ट्स a couple of times चूना और कितना प्यासे लगा ना sir you look like Marie Curie that's what I'm talking about the famous chemist हसन रहीम का और कौन सा गाना है एक तो जूना है एक और कौन सा गाना है क्या गाना है यार तो कुछ नहीं होता साइंटिस्ट तो थी ना एक और गाना हसन रहीम का क्या है यार कोई गाना बताओ गाना give me a song guys not Mand I don't like that not पीछे हट अच्छा गाना बताओ यार हसन रहीम ओजी हसन रहीम सॉन्ग्स एक तो जूना है एक और भी है और कितना प्यार है Sapphire is Ed Sheeran Or should I say Ed Sheeran, Jami Sheeran? Obladi, Oblada, count me out. I don't know. ओ मेरी राधा मुझको बता जा, दिल दिल पाकिस्तान बिफोर आर रिजल्ट्स एंड जा जा घर से। देखो, इस परचम के साए तले हम फेल हैं, हम फेल हैं। सांझी अपनी खुशियां और गम फेल हैं, हम फेल हैं। इस परचम के साए तले आप फेल हैं। मजाक कर रहा हूँ, प्लीज प्लीज, आई एम जोकिंग प्लीज। अल्लाह आप सबको कामयाब करे, डोंट कैंसिल मी, थैंक यू वेरी मच। थैंक यू जुनेद जमशेद, जुनेद जमशेद सॉन्ग्स वर ऑसम। कौन सा गाना था जुनेद जमशेद का? एतबार भी आ ही जाएगा, चलो तो सही, रास्ता कोई मिल ही जाएगा। You know. What about Eminem? Eminem more like Eminem chocolate. I don't like Eminem. I don't even understand his lyrics. Sir Michael Jackson. All I wanna know is that they don't really care about us. All I wanna da. Can you sing Kavish? Kavish is फिर भी है तू ही, कहना यही है, मिट के भी मिट ना सकी, दिल में जली जो आगन दिखी सी। पता नहीं फिर क्या लिरिक्स है। मुड़े देने ना सकी, समथिंग लाइक दैट। तेरे प्यार में दिल हार के मैंने क्या पाया, क्या गवाया, तुझको पू। अम्मी अबू आपके क्या कहेंगे? थोड़ी सी तो शर्म कर लें। अम्मी अबू कहेंगे कि आप लोग केमिस्ट्री पढ़ रहे हैं कि सिंगिंग कर रहे हैं। अल्लाह माफ करे, मुझे भी इसके बाद कॉल्स आनी है पेरेंट्स की, सर आप क्या कर रहे हैं, आप बच्चों को हराम उल हराम, अस्तगफिरुल्लाह रब्बी मिन कुल्ली ज़म्बिन। प्लीज गाइस रिसाइट विद मी। टुमारो आई विल ग्रो वन लॉन्ग बियर्ड, cut my mustache off, and then I'm going to advise students to be fraudias, and but I will make sure they pray 5 times a day. No shade at anybody, sorry guys, sorry, I'm not gonna throw shade at anyone. Hair, nobody was hurt. Oh nahi, oh nahi, oh nahi. What other song? What other song? Do you have a favorite show? Brooklyn Nine-Nine is one of my favorite. Let me also stop the recording. Yeah. Oh shit! All of this was being recorded. I'm cooked. I am cooked because these recordings go onto YouTube. Shit! I'm cooked. I'm cooked. Let me stop the recording.